Hello, in this video we'll show the matrix solution for a power series regression analysis. Here we have a data set. The first step will be we show the equation, the power series equation using chart. We use the scatter chart plot and we show the equation as label. We use power series equation and we use it as label. So here we have the equation, the power series equation 0.102 x to the power 1.47. We will also show the r square value, which is equal to 0.984. We will calculate these values using the matrix operations. So first we start with the power series equation. The power series equation, we have 0.102 times x to the power 1.47. So this is 0.102 times x to the power 1.47. Converting this to the linear form, we will have ln y equals 1 times ln b0 plus b1 ln x. So this is now converted to its logarithmic form. We have ln y equals ln b0 plus b1 ln x. Let's begin with the ln y values, which is equal to RA formula, ln of the y values. Next, we complete the 1x matrix where we have the ln x values, RA formula, ln of the x values. Now that we have the 1 ln x matrix, we can convert it to square and invert it. We use the Pijorina input inverse operation, which is equal to m mult minverse m mult transpose of this matrix and itself. Next, we calculate for the Pijorina output factor matrix, which is equal to m mult transpose of this matrix and the ln y values. Now that we have these matrices, we can calculate for the coefficient, which is m mult of this matrix and this matrix. So here we have the B1, which is 1.465. B1 is 1.465, but here B1 is 1.47, which is rounded off. B0 equals exponent of ln B0. So we have 0.1019, which is rounded off as 0.102. Now that we have both coefficients, we can now calculate for the estimated or the ln y hat, which is equal to m mult of this matrix and the coefficient. Now that we have the ln y and the ln y hat, we can now calculate for the residual sum of square or RSS. Sum x, that is the sum square of the difference of y and y hat, ln y and ln y hat. The estimates. So we have here sum x. Okay. Now we can calculate for the degrees of freedom of denominator, which is equal to rows of the dataset range minus columns of the dataset range, which is 7. Now we can calculate for the stay x, or the standard error estimate, which is equal to square root of RSS divided by the degree of freedom denominator. Now that we have the standard error estimate, we can now calculate for the standard error value of B coefficient B0, which is equal to stay x times square root of the P Jarina red. And the standard error value of the coefficient B1, which is equal to stay x times square root of P Jarina blue. Next, we calculate for the population, which is equal to rows of the dataset. You have population 9. Next, we calculate for the total sum of square, which is equal to the population times variance of the population ln y. And we calculate for the degrees of freedom of denominator or numerator, which is columns of the independent variable. We only have one independent variable. Now we can calculate for the regression sum of square, which is equal to TSS, or total sum of square, minus RSS, residual sum of square. Now that we have the values for the regression sum of square, we can calculate for the RSQ, also known as coefficient of determination, which is ESS divided by TSS, total sum of square. So regression sum of square divided by total sum of square. 0.984, which matches to our charts, R squared, 0.984. Next, we calculate for the F statistics, which is equal to the regression sum of square divided by the degree of freedom of numerator, all over residual sum of square divided by degree of freedom of the denominator. So this completes our matrix solution for power series.